Welcome to our video on section 3.3, which is proving lines are parallel. You should be on pages 9, 10, and 11 in your packet. Today's objective is to use properties of parallel lines to prove that lines are parallel. So we're going to be using all those properties that we learned in section 2, the properties about when parallel lines are cut by a transversal, but this time we are going to prove that the lines are parallel. So there's 4 different ways to prove that lines are parallel. Way number 1 is to show that corresponding angles are congruent. And that's a property that we learned before. If lines are parallel, the corresponding angles are congruent. This time, if the corresponding angles are congruent, that means the lines are parallel. So it's just the converse. Another way is that the alternate interior angles are congruent. Alternate exterior angles are congruent. And the last one you should probably be able to come up with yourself. It's that the consecutive interior angles are supplementary. So remember that this fourth property is the one that's different. The consecutive interior angles are the only ones that are supplementary. The corresponding alternate interior and alternate exterior should all be congruent. So using these properties, let's look at example 1. It says if the measure of angle 1 in the picture below is 60 degrees, what must be the measure of angle 5 so that B is parallel to K? So this time, we don't know that B and K are parallel. They're just two lines cut by some transversal A. So first thing is I need to know angles 1 and 5 are corresponding angles. They are both above their respective lines and to the right of the transversal. Because they are corresponding, that means angle 1 should be congruent to angle 5 if B and K were parallel. So we want B and K to be parallel, so that means if angle 1 is 60 degrees, then angle 5 also has to be 60 degrees. And then if that's true, then B is parallel to K. So again, angle 5 can be any measure that it wants. But when it is 60 degrees, that's the only time that B and K are parallel. So if angle 5 was 59 degrees, B and K are not parallel. If it was 61 degrees, not parallel. Only when angle 5 is 60 degrees do the lines happen to be parallel. Okay, let's move on to example 2. It says if the measure of angle 3 is 65 degrees and the measure of angle 7 is 3x add 5, find the value of x that makes the lines parallel. Okay, so again, x can be anything that it wants here. That makes sense, so negative probably doesn't make sense. But it can be any value it wants. But we want to know what's the specific value of x that will make the two lines parallel. So you pause the video right now, identify what type of angle pair you have, and set up an equation, please. When you are finished, play the video again. So you should have noticed that angles 3 and angle 7 are corresponding. Therefore, if the lines were parallel, angle 3 would be congruent to angle 7. We want to make the lines parallel, so we need to set these two angles equal. So angle 3 is 65, angle 7 is 3x add 5. Subtracting 5, I get 60 equals 3x, and then x equals 20. So when x is 20, the two lines will be parallel. If x is greater than 20 or less than 20, the lines will not be parallel. Hopefully you got that one right. If not, that's okay. Hopefully you now see your mistake. Let's move on. So the directions for example 3 are on the bottom of page 9. It says, can the given lines be proven parallel and explain why or why not? So please flip to page 10. Okay, on this first top left example, we are given two angles that are congruent. So we need to identify what type of angles are these. Well, these are sorry about that. These are alternate exterior angles. Okay, alternate exterior angles should be congruent. Here they are congruent. So we would say yes, A is parallel to B, and then we're going to say that the alternate exterior angles are congruent. Sorry, my pen is having some issues today. Okay, you try the next two on your own, please. Pause the video, determine if A is parallel to B, and then why or why not. Okay, for the second one, you should have noticed that we have corresponding angles. So they're both below the transversal and then to the left of their respective lines, and they are congruent. So we say, yes, A is parallel to B because the corresponding angles are congruent. And then this third one, angles 1 and 2 are alternate interior angles, which should be congruent. In this case, we do not know that they're congruent. We know that they're supplementary, they add to 180, but we don't know what they are. They could be 60 and 120, they could be 90 and 90, they could be 45 and 135. So in this case, no, A is not parallel to B. Alternate interior angles need to be congruent, not supplementary. So that was a little tricky, but hopefully it went okay. Let's move and look at example 4. It says determine which lines can be proven parallel with the given information. Okay, so the first one, angle 1 is congruent to angle 5. Okay, first thing I need to do is identify my transversal, which in this case is A. A is the only line that they both touch. If A is the transversal, that means I can ignore B. Okay, 1 and 5 are corresponding angles. They're congruent, so therefore C is parallel to D. Okay, so I'm going to erase this before we do the next one. 1 is congruent to 16. Okay, so what line do they both touch? Well, angle 1 touches A and C. Angle 16 touches B and D. They don't touch the same line, so there's no transversal. So this means there are no lines that are parallel. If there's no transversal, we can't have parallel lines. Okay, 2 and 14. 2 and 14. Again, they don't touch the same line. There's no transversal, so there's no lines that are parallel. There could be some that are parallel, but we can't prove any parallel. And then the last one, 3 and 10. 3 and 10. Okay, you guys do this one. Identify the transversal, and then identify which two lines are parallel, please. Okay, so we should have noticed that both of these angles touch line C, so C is our transversal. Because C is the transversal, I can ignore D. Okay, I have alternate exterior angles. They are both exterior, they're outside of A and B, and they're on alternate sides of C, alternate sides of the transversal. Alternate exterior angles should be congruent, and they are congruent in this case. Therefore, A is parallel to B. So that's okay if you didn't get that. If you have a question, write it down, and we'll be sure to answer it when you come to class. We have one property and 2 more examples, and then we are finished. Sorry, I know this video is a little long. Okay, the transitive property of parallel lines. So we've already talked about the transitive property, but this is a more specific transitive property. So, if A were parallel to B, and B were parallel to some line C, then A must be parallel to C. So if you notice, B acts as our bridge here. And then A and C are what go in the final parallel statement. So let's look at our proof, our first proof, which is example 5. It says copy and complete the proof. The measure of angle 1 is 115. Measure of angle 2 is 65. I always like to mark these in the figure. And we want to prove that the two lines are parallel. Okay, so first it says the measure of angle 1 equals 115 and angle 2 is equal to 65, which is given. Okay, then it says 115 add 65 is 180. That's just addition. Next, the measure of angle 1 plus the measure of angle 2 is equal to 180. So looking at statements 2 and 3, I somehow went from 115 to the measure of angle 1, and I went from 65 to the measure of angle 2. Well, up here, I was told that the measure of angle 1 is equal to 65, and I was told that 115, and then I was told that angle 2 equals 65. So what I did in this case is called substitution. Okay, so instead of 115, I wrote the measure of angle 1. Instead of 65, I wrote the measure of angle 2. Okay, so next statement. Angles 1 and 2 are supplementary. What does it mean to be supplementary? It means that they add to be 180. Okay, well I just said that the angles added to be 180. Okay, if they add to be 180, they have to be supplementary. So the reason for this is called the definition of supplementary. So I know we haven't seen that reason before, but it's just a definition. And then the last one is that M is parallel to N. Well, angles 1 and 2 are consecutive interior angles. We know that if the consecutive interior angles are supplementary, the lines must be parallel. So for our reason, we can say consecutive angles supplementary. That proves that the lines are parallel. I know that was confusing, so we're going to do one more together. Example 6 again is on the bottom of page 10 and it continues on to page 11. It says in the figure R is parallel to S and angle 1 is congruent to angle 3. Prove that P is parallel to Q. So I always like to start by marking in the figure what we are told. So we are told that R and S are parallel. And we are told that angle 1 is congruent to angle 3. We need to prove that P and Q are parallel. So our first statement needs to be that R is parallel to S and angle 1 is congruent to angle 3. Reason? That's just given to us. Okay. Now if I look at R and S, my parallel lines, I notice that angles 1 and 2 form a special angle pair. They are corresponding angles. So my next statement could be that angle 1 is congruent to angle 2. And that's because if we have lines that are parallel, the corresponding angles have to be congruent. Okay, 3. I have angle 1 is congruent to 3, but angle 1 is also congruent to angle 2. Therefore, angle 2 has to be congruent to angle 3. This is that weird property. This is the transitive property. Okay, so now I know that 3 and 2 are parallel. Or are congruent, congruent. I notice that they both touch R. That means that R is a transversal, so I'm going to ignore S. Okay, 2 and 3 then are alternate interior angles. If the alternate interior angles are congruent, that means the lines are parallel. So now I can say P is parallel to Q, which is what I wanted to prove, because if the alternate interior angles are congruent, then I know that the lines are parallel. I know that this is confusing, so if you got lost, please rewind and listen to me explain the proof again. When you come to class, you will be expected to do a few proofs on your own, although we will start together. If you have any questions as to where I got any of these statements, any of the reasons, anything like that, please feel free to write them down and ask me tomorrow. Thank you.